Hello and welcome, my fellow physics mortals. We're going to work on work and energy on this TI84 calculator program. Let me go back and I'll just show you it's a physics mechanics solver, the TI84 calculator program, available at mcstutoring.com. I'll put the description, or I'll put the link in the description, so don't worry about that. So again, we're going to work on work and energy problems. And look, we got work, kinetic energy, KE, potential energy, PE, spring potential energy, and power. So let's get right into it. So we're going to do work first. And then notice we can solve for work, force, or distance. And it gives you the formula right here, which is really convenient for all the submenus that will give you that. So calculate the work done by a 25 Newton force pushing against the box over a distance of 4 meters. So this isn't going to be given to you, what I'm going to box right here. Obviously, your teacher's not going to give you the solution. You're probably not giving givens. But I think it is helpful to write down, okay, the force is given and the distance is given. So we're trying to solve for work. That's the unknown. So we're going to solve for 1. And then, oh, what's the force? Oh, it's 25. See, now it's easy peasy. Just type in like what you have, the F and the D. So you get work equals force times distance, so 100. In this case, 100 joules. Joules is a proper unit. I did get dinged for units, so I would recommend memorizing what units you're going to be using for each type of problem here. Okay, and then we're going to do another work problem. In this case, a force does 200 joules of work. Let's change the color here. 200 joules of work over a distance of 8 meters. What's the magnitude of the force? So in this case, we're going to go again to that work equation here. And then we want to find out the force. So we're going to solve for F. And then, oh, what is the work? Oh, it's 200 because the work is 200 joules. So 200 right there. And then the distance, oh, that's 8 meters. That's great. I'll type in 8. And the force is 25. Okay, and then again, you want to make sure you have the right, you label units correctly. And some physics teachers can be a little, tricky, and they give you centimeters, things like that. So just keep in mind, you might have to convert to meters and then joules for the force. Okay. Then we go back. We're at kinetic energy problems now. So that's going to be the second equation. KE equals 1/2 mv squared. And let's see what we're going to try to solve from this first one. First one says calculate the kinetic energy of a 0.5 kilogram ball. So the mass is 0.5 kg, moving at 10 meters per second. Okay, the velocity is 10 meters per second. So we're trying to solve for, in this first one, KE, kinetic energy. Oh, and what's the mass? It's 5. And velocity is 10. That's great. And then we get 250. And again, if your teacher wants you to write the equation itself, you have it right here. It's super handy, 1/2 mv squared. So we've got 25 joules as the answer. That is fantastic. Okay, let's go to option, or question 2 for kinetic energy. So again, we're going to choose 2 in the work energy submenu, 2 for kinetic energy. And then we're trying to find velocity. What is its velocity? So we're going to solve for V. And then kinetic energy has 100. So the KE is 100. And the mass is 2 kgs. And you're going to get, again, the formula. Velocity equals square root of 2 times kinetic energy divided by m, meaning the mass of the object. So you get 10 meters per second. Fantastic. We're going to go on to gravitational potential energy. So that's actually just under PE, like regular potential energy. I mean, not there's a regular and irregular, but like regular potential energy versus spring. So we're going to go to PE. And then calculate the gravitational potential energy of a 3 kilogram book. So the mass is 3 kilograms. Lifted 2 meters above the ground. So H is 2. And then, okay, now here's the G thing. I know this is going to cause consternation, especially when the AP Physics hoity-toity crowd, they're like, G is 10 meters per second squared. I'm like, oh, you guys have no idea. Okay, but again, plug in 10 if you're in AP Physics in the States. So we're going to calculate for potential energy. Okay, what's the M? The M is 3 kilograms. The G is 9.81. 9.8 if you're in a different class, or 10 if you're in AP Physics. So the answer will come out slightly differently. The height is 2 meters, so I'm going to plug in 2. And great, we get 58.86 units, or joules in this case. Okay, fantastic. Let's go back to gravitational potential energy, otherwise known as, regular potential energy. Now, how high? So the height is what we're solving for. So the H there. Okay. What's potential energy? 50, because it's saying to have 50 joules of potential energy. What is the mass? Oh, it's 1 kg. And for this case, we're going to assume 9.81. Don't flame me in the comments or anything. Just if your teacher uses a different unit, hey, that's cool, man. Just roll with it. Roll with it. So I think this is going to round to 5.10, depending on your teacher's use of significant figures or significant digits. Don't want to get into it right now. This is neither the time nor the place, my friends. But just know that some teachers have different rules regarding that in chemistry and in physics. Okay. Spring potential energy. So we're going to go spring PE, baby, number 4. Okay. Find the spring potential energy. So I think it's going to be option 1. For spring with K equals, okay, K is basically the, I think that's the spring constant. And it's different for each little spring. So we're going to go 100 Newton meters. And then compressed, and that X is the distance here, just so you know. So it's 0.2. And there we go, potential energy, sub S. I couldn't do a subscript. Maybe you can, and I'm just not smart enough, and I'm just going to be okay with that. It's 2. So 2 joules. Yes, we have an answer that fits. Okay, good. Again, we're going to go to spring potential energy. And then we're looking for the compression, which is usually a distance over which a spring is compressed. So compression, like, think of like squeezing something down, like squeezing a spring down. So we're going to solve for 3. Option 3 is X, solve for X. So the potential energy of the spring, okay, it has 8 joules of potential energy, good, 8. And K is 200 newtons per meter. And then X is 0.28, we're going to round it to 2.283 meters. Great, okay, good. Good. Just to show you how this program works, again, it's available at mcstutoring.com. M is in Mary, C is in Charlie, S is in Sam. mcstutoring.com, your source for TI84 calculator programs. And what's selling really well right now, I'm just going to say it, the physics solvers, both mechanics is 1 solver, and then electricity and magnetism is another. And then we got this, and a chem solve. I have 1 chem solve program. Videos coming out on that pretty soon, probably later this month, or this month's almost ended, sorry, probably February 2025. Okay, in any case, power problems. So we've got calculate power, so we're going to solve for P. When 400 joules of work is done, so what is the work? 400 is done, and what's the time? Oh, time is 5 seconds. Okay, great. So again, gives you the formula, P equals W over T, we get 80, and the units for power typically in the SI world is watts, so we're going to go 80 watts there. Okay, then we'll go back to power once again. How much work is done in 3 seconds by a 150 watt motor? So again, we're going to solve for, well, not again, in this case we're going to solve for work. And then what is the power? Oh, it's 150 watts, so 150. And then time is 3 seconds. And again, I think we're assuming seconds here for everything. So if it's minutes, you got to multiply by 60 to get seconds. So work is 450. In this case, work is joules. Okay, cool. And then we're going to go one last power question. How long? Ooh, I think we're going to go time, solve for T. 200 watt motor, do 1,000 joules of work. Oh my goodness. So the work is 1,000. So there we go. And then the power is 200 watts. And there we go. Time is 5 seconds. So if you like it, click like. If you don't like it, be helpful. And I mean, you can hit the dislike. That's okay. But say, hey, this is what can be added to your program or changed to your program. Constructive criticisms always asked for and solicited, and you can contact me at the mcstutoring.com site, because people have said, hey man, you got errors on the gas laws of your ChemSolve program, or hey, there's some gas laws missing in your gas laws in your ChemSolve program. Guess what? I fixed those. And I sent them out. I sent out the fix to everyone who bought the ChemSolve program. But look, good luck in all your physics stuff. And guess what we're going to come back with? We're going to go over momentum problems, rotational problems, and gravitational problems. Knock on wood if I'm healthy later this week. Okay, good luck, and I will catch you next time. Bye-bye.